So hi everyone and welcome for another video. In this video I'm gonna tell you about binary tree and data structure. So what is binary tree and why binary tree is important in data structure? So binary tree is a type of tree data structure, right? In which nodes which each nodes has most two children, referred to as the left child and the right child. These children are also binary trees themselves. They can also like uh, can make another uh, child. The binary tree in data structure is recursive in nature, as each subtree is also a binary tree. So, why is binary tree is important? So why binary tree is important? So here's some reason why binary tree is important. Efficient searching and sorting. Binary trees can be used to efficient search for and retrieve data. The structure of a binary tree allows for efficient searching algorithm like binary search, which has a time complexity of 0. In balanced binary trees, binary trees can also be used as the underlying data structure for sorting algorithms like heap sort and binary tree sort. Quick insertion and deletion. Binary trees provide efficient insertion and deletion operations. The tree structure allows for easier reorganization of nodes during insertion and deletion, making it faster compared to other data structures like arrays and linked lists. Representation of stratical relationships. Binary trees are often used to represent stratified relationship between object and entities. For example, in file system, binary trees can represent the stratified structure of directories and files. In databases, binary trees can represent the structure of indexes or the organization of data. Tree-based algorithms. Many algorithms and data structure are based on binary trees or a variation of them. Examples include binary search trees, eval trees, and red block trees and heaps. These trees-based structure are algorithm form the foundation for various computational problems and optimization of techniques. Balanced tree structure. Balanced binary trees, such as eval trees and red block trees, ensure that the high of the tree remains balanced. This balanced property allows for efficient operation and guarantees the worst case time complexity for various operations like searching, insertion, and deletions. Though binary tree is important, so this is a summary of the binary trees. So binary trees are important to the efficiency in searching and sorting, quick insertion and deletions, representation of strategical relationships, the role as foundational for tree-based algorithm, and the ability to maintain balance for efficient and operations. So let's move on to the code that I made earlier. So hi guys, and so this is the code that I made. So first we made the class, which is the public class BT node. So uh, so in the bottom in the public class, we make a int info, which is the uh, this info variable is an integer that stores the data associated with the nodes, and we made the BT node L sun, which is represent the left side of left child of the node, and we made BT node R sign, which is which this variable represent the right child of the node, and at the lower part we made again a constructor we made this constructor of the BT node class. It takes an integer. It is oh, as a parameter when a new node BT node object is created. This constructor initialize the instance variables. So we made info, which is the variable, is set to the value of O, which represent the data stored in the node. The LSUN and RSUN uh, were set to null, indicating that the node essentially has no left or right child. So we made the method, which is this we name it PST, which is represent as binary search tree. So we made a root here. So BT node root equals null. So here we made a method again, which is the inject. So this method which is the inject is used to insert a node with a given info into the binary search tree. If root is null, if root is null, if root is null, a new node with a given data is created and assigned as the root here. If the tree is not empty, the method enters a loop to traverse the tree while find the appropriate position for insertion. It uses JOption that show option dialog to prompt the user to choose whether to insert to the left or to the right of the current node, which is here, which is in this particular line. So the the loop continues until a valid choice is made. If the chosen direction, which is here choice, is J option pane that yes option, indicates which is indicating left. It check if the left child, which is the LSUN, of the current node is null. If so, it creates a new node with a given data and assign it as the left child. Otherwise, it updates the current of the left child and continues transversing. Here, in else, if the chosen direction is J option pane that no option indicate the right side, it follows similar logic but for the right child, which is the RSUN. If an invalid input is provided, it display an error message with using the J option show message dialog, which is here, which is this line, and here is this line is where the right side of the tree. so we made a method here which is display t. So this method is used to display the binary tree structure. Here it creates a string builder named treeString equals new treeString to build a string representation of the tree. So it appends the header line binary tree to treeString. It calls a private helper method display t to recursively transfer the tree and appends the node information to treeString. So here, so finally, it displayed the build tree string using the J option message dialog. So here, then and this and we made a private method here, which is the display t. So this method is used to recursively transverse the tree and appends the node's information to the tree string. It takes two parameter node representing the current node being visited and the tree string, which is the string builder to build the tree representation. So here, sorry for that. And if the current node is not null, here if the current node is not null, then it appends to the root information to tree string. It appends the information to the left subtree of the current node, or we call left node. So here, sorry for that again. It appends, so here, then it cursively calls display t. So it's here, display t. I mean here, then it's going to be called display t on the left and the right, subtree of the current code. I mean node. Let's move on in the next method. So we made a method which is the public void display tree in order. So this method is used to display the elements of the tree in an in order transversal. If the method is null, then indicating an empty tree is display, and it display a message saying the tree is empty using the J option dialog. So if the tree is not empty, it creates a string builder named tree string to build the transversal string. It appends to the header line in order transversal to tree string. It calls a private helper method display in order to recursively transverse the tree in an in order manner and appends the node information to tree string. So finally, it displayed the built tree string using the J option dialog message dialog. And so here in this in the remaining methods, which is the display post order here, the display in order, which is this method, and the display post order, which is this method, and the display pre-order here, this method again, and display t pre-order, and this display pre-order are similar to the in order that we discussed earlier. So we made a method, which is this one. We make a public boolean search in data. So this method is used to search for a node which is the given data in the tree, and simply calls the private helper method, which is the search node, and it will returns the result. The search node method takes a node and the data to search. So here we make a search node, and then if the node is null, it indicates that the end of the subtree without finding the data, and if it's return and returns false. If the info of the node matches the data, it returns, which here it returns true. Otherwise, it recursively calls search node on the right and the left subtree of the node and returns the logical OR here. Look, my bad. And returns it returns to the logical OR of their results.